The Colorado River is a 1,450-mile river that cuts through the western United States. Starting in the Rocky Mountains and moving south, the river has steadily flowed. At some parts of the river, it has eroded up to 2 billion years worth of rock, including but not limited to limestone, sandstone, shale, granite, and schist. The limestone at the beds of the river show that some of the rock surrounding the river was at one point coastal. The rafting clips are all taken from a spot on the Colorado River called Westwater Canyon. The Precambrian rocks here vary from coarse-grained igneous to lower-grade metamorphic. The igneous rocks are part of a mitigate complex, which was a crustal intrusion of magma that cooled in an actively deforming environment. All of the different observable layers show all the different kinds of dramatic changes in the area over the last 2 billion years. This doesn't mean, however, that the Colorado River is 2 billion years old. Through Steno's law of cross-cutting relationships, we know the Colorado River was the last entity to enter this location. The Colorado River is only about 100 million years old. The Colorado River formed soon after the Rocky Mountains started to rise. At the time of formation, which was approximately 100 million years ago, the Pacific Ocean was much further inland from where it is now, but it does not explain the phenomenon of the rise of the Rockies. The existence of the Rockies is considered extraordinary, as the Rockies greatly exceeded the typical range of 200 to 400 miles inland from a subduction zone boundary. The Rockies still had the ability to rise due to the fact that the angle of subducting plate is significantly flatter, which moved the focus of the mountain building further inland. This shallow angle greatly increased the friction and other interactions with thrust to build exceedingly high Rockies. These mountains are significant to the Colorado because they are the origination point of the river. The river has gone through some changes in the last 100 million years too, such as the primary location of outflow. Sediments carried from the plateau by the Colorado River created a vast delta of more than 10,000 cubic miles of material that walled off the northernmost part of the Gulf in approximately 1 million years. Cut off from the ocean, the portion of the Gulf north of the delta eventually evaporated and formed the Salton Sink, which reached about 260 feet below sea level. Since then, the river has changed course into the Salton Sink at least 3 times, transforming it into Lake Cahuilla, which was a massive lake ranging into what is now California. The light green that you see surrounding the body of water is representation for the lower altitude where the ancient lake was. The Salton Sink is actually a tectonic pull-apart basin as well. Though a large reason why the basin is so much further below sea level is the fact that there was only one inflow and outflow of the Colorado, the basin is also trying to pull away from itself. The Salton Sink is a low area in a broader topography called the Salton Trough, where, by combined actions of the San Andreas Fault and the East Pacific Rise, the basin is stretching and sinking. Through movements of the faults, the strip of land sinks in a process called subsidence, where the fault are roughly parallel to each other. At the bottom of the Salton Sink, the east wall of the trough is the San Andreas Fault, and the west wall consists of the peninsular ranges. This is the basin and range topography that surrounds us here at Westminster. The Colorado has lent insight into both the fault location and movements of sediment, as well as given us an idea of the conditions of the location on the continent by exposing the layers of surrounding rock. Throughout the Colorado, many different observations can be made about the geography of what is now North America, and further lend us insight to other parts of the world.